Hello everyone, welcome to the another session of digital signal processing. Today we'll be learning another technique of calculating the convolution that is called as block convolution. So here we will convolute long sequences by two methods, overlap and add method, overlap and save method. So this block convolution is also called as fast convolution or section convolution, the way we carry out the process of convolution. So when we are implementing the linear convolution for FIR filters, the input sequence xn is much longer than the impulse response of the system, that is hn, because the real-time signal is coming for a long duration and we are sampling that particular signal at a rate of say 128 Hz per second or say 512 samples per second. So when we calculate the convolution, we take for the example 4 samples or 8 samples, but in real time that is not the case. The sequence may have 500 samples or 1000 samples. So what we perform, the circular convolution can be performed by padding zeros into the hn to make the length equal to xn, as the process is called as zero padding. Now this output cannot be obtained until I am obtaining all the samples of the signal, but if I am processing in real time, the samples may not be present at t is equal to 0. And second thing is, I have to store all the samples. So size of the register, the microprocessor I am using for the processor, that may also be limited. So we have taken a method out, a shortcut method by which we can calculate the convolution of a long sequence using section method, and that is also called as a fast method, because even if the signals or the future samples are not present, I'm starting my process and calculating the convolution for these samples which are present at this particular time. So when we take it for the long sequence, what do I see? That implementation of FFT and the size of the memory that is needed, that may become impractical. So because I know in the present day the maximum length of the register that is available is 64. So if I have 500 samples into my signal, I may not be able to perform the convolution at once. So I have to perform a technique which is called as block convolution, dividing the samples into subsections. So to eliminate these problems while performing the filtering operation or performing the convolution in the frequency domain, two signal segmentation methods are used. One is called overlap and add, another is called overlap and save. So to perform this fast convolution, we perform the sectioning or grouping of the long input sequence into blocks or batches of the sample, and the final convolution of all the batches that may be combined either using overlap and add method or overlap and save method. So let us see these techniques one by one. So talking about this overlap and add method, let me take a sequence xn which has say 8 samples which are periodic. So they will keep on repeating one after another, but this is one block of 8 samples, and the length of register which is available with me for processing or carrying out this convolution is 4. So what would I do? This 8 samples would be divided into 4 and 4 samples. This is what I'm talking about xn, and the sequence hn may be of any length, maybe 2, maybe 3 or maybe 4. So this first block is referred as x1n, second block is referred as x2n, and I would take the convolution of these two blocks individually with hn. I'm talking about linear convolution here. So let me put up this linear convolution symbol here. So I'm obtaining two sequences convoluted. Now how to obtain the final output yn out of these two sequences? The yn would be coming from y1n and y2n by overlapping them by how much amount? If length of hn is say m, then these two sequences would be written overlapping with each other by m minus 1 unit. For example, the length of h is 3, then I'll overlap these sequences by 2 and add up all the samples which I have received. So the final yn would be obtained. So this is what I call as overlap and add method for calculating the section convolution. Let us see the same thing with the numerical example. This is my sequence which have samples here, and here also, and this is a sequence which is periodic. So let me take all the samples which come during one period, say 0 to 7. So 8 number of samples are here. Hn is having 3 samples. So the length by which I must overlap 2 sequence is 3 minus 1, that is 2. So this 8 samples which are 0, 1, 2, 3, 4, 5, 7, they would be divided into 2 sections, assuming the length of register is 4. So equally divided into 2 segments of length 4. I'm getting one sequence as x1n, second sequence as x2n. These 2 sections would individually be convoluted with Hn. Hn is 1 to 1. So let me perform the convolution operation and obtain all the samples. So length of the sequence which I am obtaining here is, this is 4, Hn is 3. So 4 plus 3 minus 1, the output sequence should have 6 number of samples after convolution. Then x2, second part should be convoluted. Again, that is having 4 samples, 3 in Hn. Again, I would get 6 sample in the sequence y2n. The initial sequence which I obtained was y1n. I'll write down these 2 sequences here, y1 and y2, in a way that they should overlap with each other. Overlap by the amount m minus 1. 3 minus 1, that is 2. So I'll write it, last 2 bit and first 2 bit of these 2 sequences are overlap, and I will start writing at 0, 1, 4, 8, add these 2, 8, 4, 12, 13 and 3, 16, and all other sample. So what I'm performing, I'm overlapping it by amount 2 and adding these overlapped bit to obtain this final sequence yk. Now this is one periodic convolution output. If I keep on performing these block convolution, say for the other part of the sequence, the answer would always be periodic. So this is how I can achieve the convolution of long sequences, particularly they had to be periodic, using overlap and add method. Second method is my overlap and save. I also call it as overlap and discard. I'll see why I call it as discard when we'll start combining the result. Again, I have sequence, say it has 8 samples, but now the length of the register is some odd factor out, say 6. So I can create one sequence of length 6 which would have individual samples, but second sequence which I would create, it would always be of length 6, but it would have some repeated numbers or samples from this sequence. So there is already some kind of overlapping which is existing here. So how much overlapping should be there? Again, the length of the sequence Hn is m. So how much overlapping should I perform? M minus 1 overlapping. So this sequence would be overlapped by this sequence by an amount of 2 units. And finally, I would again process it by convoluting individually with Hn, and 2 sequences, that is y1n and y2n, they would be overlapped, and finally the overlapping bits would be discarded rather than adding, as in the case of another method, overlap and add. So we'll see this again with an example. The same sequence has been taken in which one unit is made up of these samples, other units are repeating. Again, the sequence is periodic. Same Hn has been taken, but the length of the register is 6 bits. So how do I divide this particular sequence here? I would take first sequence as 0, 1, 2, 3, 4, 5. 6 samples are there. In the second sequence, 2 samples are individual samples are left, 6 and 7. So 2 samples would be taken from the previous sequence, that is here 4 and 5, and 2 samples would be taken from the upcoming sequence, that is 0 and 1. So here I have created my x1n and x2n. So the difference between 2 techniques is only creating the blocks, how I'm creating the blocks. So once these two blocks have been created in overlap and safe method, the performance of convolution remains the same. I'm obtaining my sequence y1n. I'm obtaining my another sequence, that is y2n. And then final result is overlap and discard. So once I have taken the convolution of my x1 with hn, I'm obtaining first output as y1n. This convolution can be taken by any method, maybe tabular method, wherever we feel comfortable. Second sequence comes out to be y2n. Now how to combine it? I would write y1 here, I would write y2 here by overlapping their bits. So again, the length of h was 3, overlapping would be 2. So here, these last two bits of first sequence and first two bits of the second sequence, they are overlapped with each other. Now how to combine this? These samples would come as it is, but these overlapping bits, in the previous example we were adding these samples, but here we would discard these samples, we would completely ignore these samples and would write the samples of above sequence 12 and 16 and other samples as it is. So that's why the name is overlap and discard, because initially when we created these two sequences here, the first sequence and second sequence, we had already overlapped these numbers 0, 1 and 4, 5 of the first sequence. So later section, when we are creating the final result, we have to discard these overlapping bits. So this is the final result of the convolution using overlap and safe method. But we see that the convoluted output is same in both the cases. The difference is only because the length of the register that is available with me was different. So whatever limitation is there with me, that limitation can be solved by these two methods. In one method, I can create sequence of equal lengths with individual samples, no overlapping, no repetition. In the second method, I cannot create two sequences which are having individual samples, rather I have to repeat these samples. So in that case, I am using overlap and discard technique. So in this case, any length of the sequence which is coming here, which is periodic in nature, can be convoluted step by step, even if I have limitations of register, if I have limitation of memory with my processor. So this is how we have discussed as many methods of calculating the convolution, maybe a long sequence, maybe aperiodic sequence or periodic sequence. So looking at the signal and the properties of xn, I can choose any of the method out of the methods we have discussed for carrying out the convolution. So this is all about the convolution. In the next session, we'll be discussing about newer transformation technique, which is used for calculating discrete Fourier transform and known as fast Fourier transform. So that's all for this session. Thank you.